So this is the plant description engine, which is a very useful support system and tool when you want to design large industrial automation system in a multi-vendor perspective with integration according to plans. The main objectives are two. First, to support making plans for multi-vendor integration, where ready-made Arrowhead systems are delivered by vendors independently, and there is an integrator that uses them as Lego blocks and constructs the glue for interconnectivity. We use late bonding in service-oriented architectures, and through orchestration, we make sure that the system connects at runtime according to the plan. The second objective is to monitor that the currently active plan is followed. We check if a system or service is not present, you get an alarm. We check if an unknown system occurs. It raises an alarm also then. The plans can be set up in variants according to plan A, plan B, plan C, and so on. And the active plan is used by the PDE to populate the orchestrator to make sure that we fulfill the plan at integration. The plant description engine in Arrowhead looks like this. We have the monitoring and management part of the PDE to the right, in interfaces to the core systems through management interfaces, to service registry, to orchestrator, to authorization. It also integrates with service provider and service consumers, where service consumers produce a monitorable service to be able to be monitored. We have a use case with 4 different parties. We have the LTU providing a Fisher factory with lots of sensors. We have an operations center backend with a data store produced by Jotne. We have the integrator role also by LTU, where the cloud uploader is built. And we have the operator and constructor of the PDE by Sarepo. Plan A, we listen to sensors I7, I8, and I9. We can switch to plan B and listen to I7, I5, and I4. A demo follows.
The Fisher Technic factory is registered into the LTU Arrowhead local cloud as a provider, and it offers 3 services. The sensor value service provides the status of all 9 sensors. The actuator value service provides the status of all 10 actuators, and the monitorable service monitors the provider system. Now, all these services are registered into the service registry with multiple service instances with the same service definition, but with different service URIs and metadata. For the sensor value service, we have total 9 service instances for getting the status of all 9 sensors, and the same applies for the actuator value service. Then for the monitorable service, we have total of 20 service instances for getting the system ID and inventory ID of all sensors and actuators, and for monitoring the provider system. Now there is an integrator called Cloud Uploader, which acts as a consumer in the Arrowhead local cloud, and it consumes the sensor value service and sends the sensor status to another cloud in Yotna through intercloud. Now, in order to establish this communication between Cloud Uploader and provider, there should be store rules defined in the orchestration system. Now, the new core supporting system, which is called plan description, is able to create those orchestration rules automatically through creating plan description entries. So here I will create 2 of such plan description entries. So I have created 1 entry, which is generated with ID 0. I'll create the second entry. It is with ID 1. So the first entry I showed, it is allowing the Cloud Uploader to avail the first 4 sensor value service instances for getting the status of sensor I1 to I4. And for the second entry, it is creating the rules which will allow the Cloud Uploader to access the last 5 service instances of sensor value for getting the status of sensor I5 till I9. So now let me activate one of the rules. So I have activated it now. So if we check the store rules, we will see rules getting created for accessing service from I1 to I4. Now let me start the Cloud Uploader. I have already started the provider system. So now the Cloud Uploader should start getting the services from getting the status from I1 till I4 and send it to Yotna. Now while it is doing that, let me switch the rule now. And if I query the orchestration store, you see it is changed from I5 to I9 now. So if I check the Cloud Uploader, now its behavior is changed. It started getting the status from I5 to I9. So the PD system can not only create multiple set of orchestration rules for connecting a consumer to a provider. If needed, it can also switch between those rules at runtime.